So just wait for a moment because only 12 people have joined. So far, as part of big data ecosystem overview, we have spoken about HDFS, Yarn, and then Hive, and then Spark. Okay. So let's try to understand the context of each of these technologies. And also, I'm sorry, I'm a bit behind in updating Kaizen, but the videos are on YouTube. All the videos are on YouTube. I will take care over this weekend. All the videos I will be placing on Kaizen. Okay. Um, Before we get started, let me also uh, add it to the playlist. Okay. So far we have spoken about those four technologies. Like that, there are a number of technologies, but especially Hive and Spark itself constitute of 60 to 70% of big data ecosystem. If you are good at Hive and Spark, you can start your career as data engineer. Okay, and then the next important technology is Kafka, and we will see that at a bit later point in time. That being said, let me go back to the introduction PPT. I hope everyone have gone through that introduction to big data session or introduction to data engineering session. If not, I will recollect up to some extent, which up to that point where whatever talking is relevant to that. Okay, so let me go to the PPT. Okay, this is MP4, not PPT. Sorry, this is the one which I'm interested in. That's why it is not coming up. Okay, and if you go through this video, we have gone through this list. Okay, and you can see there are a bunch of tools in this. Um, 1 minute. Okay. Okay. So these are the technologies which we spoke about. You have HDFS, you have Mapreduce, you have Yarn. These three things we have seen up to an extent. There are also technologies like Hive, Spark, all those things in this. Okay. So to begin with, you don't know what they mean, but as you proceed, you need to understand not only the purpose of those things, but the categories of those things. Okay. Now, if you go to the categories of these tools, they are categorized into four. One is file system, second one is data ingestion, third one is data processing, and fourth one is visualization, and fifth one is support. Okay, so all those technologies will be part of these categories. For example, HDFS is a file system. Like that, if you are familiar with Amazon, there's a technology called Amazon Web Services. and there is a file system called S3. Okay, like that there are n number of file systems which can be used in big data world. And then data ingestion. I haven't covered anything yet as part of data ingestion tools and technologies. Then comes data processing, and as part of the data processing itself, we get this Hive, uh, Impala, Spark, etc. All those things come under data processing. Visualization, there are tools like Tableau, ClickView, etc. So I'll be demonstrating even using Tableau at a later point in time. It is not purely big data technology, but you can connect Tableau to any database, including big data databases, and generate reports out of it. Okay, what is a report? Pie charts, uh, histograms, line graphs, whatever you see with some pictorial representation into your data is called as visualization. Okay, so visualization is very, very important. It's if you cannot, it actually helps in understanding your data better. But it's not that complicated. It's very straightforward. The complexity hides behind processing the data than visualizing the data. So this is the pictorial representation of all these categories. So you have file system underneath. The category of data ingestion tools typically get data from outside world into file system, whatever we categorize as file system. The category of data processing will actually process the data. It takes data from file system, process the data, and store it back to the file system or store it back to some external database. It can be within the big data cluster. It can be outside also. And then visualization, once you have the data on the file system, you can actually visualize by connecting tools like Tableau also. Okay. Now let us talk about the data processing technologies. So the data processing can be broadly categorized into batch, real-time, and streaming. Okay, when it comes to batch, either we have to use Mapreduce or Spark. Okay, so the difference between Mapreduce and Spark is Mapreduce is IO driven, Spark is memory driven, and hence Spark is much faster in many cases. So 90% of the batch processing use cases will be done using Spark. There are some exceptions where you have to use Mapreduce because you cannot. So if you have to process a petabyte of data every month, there is no point in creating a cluster with a petabyte of memory. We will get into those details at a later point in time. Okay. Typically, we create cluster for our regular usage with respect to Spark. And if the resources are not enough to process huge volumes of data, then we will use MapReduce based tools in the same cluster. MapReduce is not that memory intensive. Hence, even though it's slow, it can process very high volume of data, even though the data does not fit into the memory. Okay. Then comes real-time operations. So as part of the data processing, we also do real-time operations, and the NoSQL databases and ad hoc querying tools like Impala, Presto, Spark SQL can serve that purpose. And then streaming analytics. There you have to use Spark streaming or Flink or Storm in conjunction with tools like Kafka, which is kind of a data ingestion tool. Okay, you will understand at a later point in time. So now these are the different file systems which are categorized in big data world. In big data, we use these are the file systems. File system is not text file or PDF file or doc. File system is the way hard disk is formatted. Okay, and HDFS is a logical file system which works on top of physically formatted file system. Typically, at the hard disk level, the hard disks are formatted using ext4, and then on top of it, the logical file system comes into picture. There is a concept of formatting in HDFS also. Okay, And then you have S3, Azure Blob, etc. These are the technologies which store files in a particular way. Okay, and then for data ingestion, which we'll be talking about today at a high level, these are the tools that comes into picture: Scoop, Flume, Kafka, etc. Scoop is from to get data from relational database such as MySQL into HDFS. Flume and Kafka are to get data in real time. Okay, so there can be static data in the database which you want to read. There can be data that is being updated at regular intervals, which we have to fetch continuously. So in the latter case, we use Flume or Kafka, and we will be seeing a high-level overview about those things. And then for data processing, because data processing is the major part of the entire ecosystem. We have Spark, Mapreduce, and Hive. All these things come under this only. Okay, that's why I have mentioned high-level categories: batch, real-time, and streaming. In batch, we use Mapreduce or Spark, and as part of the course, we are talking about Spark. And then real-time, we have HBase, etc. We have already seen MongoDB. MongoDB is the database which can be used in real time. Again, to process the data in real time, we typically use programming languages like Scala, Python, etc. Okay, there is no specific technology which actually process data in real time. You have to typically develop applications based upon your requirements for real time purpose. Okay, and then streaming, we will see streaming analytics at a later point in time. So I hope you can relate of whatever I am trying to cover. We have covered HDFS as part of the file system. As a developer, if you understand the commands or APIs to interact with this, that is more than enough. And the APIs are same, whether you read it from HDFS or if you want to read it from S3 or Azure Blob, still you can use the same API, sc.text file. Only the URI will change. URI means it looks like URL. It starts with protocol like HTTP or HDFS or S3, etc. By default, if you do not specify, it will use whatever technology it is integrated with, whatever is the default. Otherwise, you have to specify starting with the protocol, such as S3, HTTP, HDFS, WASD for Microsoft Blob, etc. Other than that, the API remains same, but when it comes to cloud-based storage like S3 and Azure Blob, you need to authenticate with them. For that, there is something called access key and secret key. I'll be covering those things when we talk about AWS at a later point in time. Okay. The point I'm trying to make is, as a developer, if you understand how to read from one file system, it's the same thing which you have to follow with other file systems in most of the cases, except for some differences such as authenticating with the cloud-based storage like S3, etc. Except that everything else is same. Okay. And then as part of the data processing, we have already seen Spark at a high level. We will get into the details starting from next week. Okay. And the next technology which I'm talking about, even Hive falls under batch data processing. Okay. Hive, Spark falls under batch data processing. Hive can run in different contexts. By default, it runs in MapReduce context, but you can also run Hive queries in Spark context. It's just a SQL structured query language which can work in different contexts. So it executes completely in a different manner depending upon the context you are trying to execute Hive queries. But the syntax perspective, it is same, whether you want to run in Spark or whether you want to run in MapReduce or any other context, the syntax will remain same. But the way it compiles and it runs in the backend to process the data can be significantly different. Okay. So again, if you know Hive, you know Impala, you know Presto, you know Tez from the syntax perspective. So now we have already covered Hive and Spark as part of batch data processing. And another technology which is kind of legacy is Pig. That also fall under that category. Before we get into very brief overview about Pig, let me tell you something here. Pig is not very good technology. Okay, it looked like Spark, like Scala or Python programming language, but it is not as flexible or as foolproof as those programming languages. Okay, so the only reason why Pig came into picture is uh, to begin with we have only HDFS and MapReduce. So Hadoop means HDFS and MapReduce. Okay, and writing data processing logic in MapReduce is quite complicated. For example, if you want to join two data sets and get revenue for each date, if you have to use MapReduce, it takes at least 1 week of time. Okay, for decent developer with some knowledge of MapReduce, it takes at least 1 week of time, and hence, and joining is a very common use case. So to cut down the development timelines, they came up with the higher level interfaces. Examples are Hive, Pig, etc. So Hive is for those who are familiar with SQL. But some people are averse towards SQL. They don't like SQL, especially those who claim to be solid software developers or hardcore software developers. They hate SQL. Okay, and they prefer to script because they feel that it gives a lot more control to them as part of scripting. Traditionally, the scripting is done with Perl, Python, etc. Okay, so those who don't want to use SQL, they created scripting style interface or language to process the data. It hides the complexity, lot of complexities under the hood, and hence the development timelines can be low without writing SQL type of queries to process the data. Okay, so on the cluster we have Pig. I didn't use Pig recently. If you say Pig, it will actually similar to Hive, it will launch the command line interface, and you have commands like load, count, etc., which you can use to process the data. So if you don't use SQL or Hive or Pig to, if you try to write Java MapReduce code, first you have to create a class, you have to create a function which set the job properties, and then you have to write, you have to extend a class called mapper, and you have to write logic for row level transformations, filters, etc. You have to extend a class called reducer. You have to write logic for aggregating or joins, whatever it is. So even to write simple program like word count, it takes at least 70-80 lines of code if you use traditional, Java MapReduce. Pig or Hive both simplify that. Okay, similar to Spark, if you have to load the data, you just have to give the variable name order items equal to, I think it's load, and then you have to give the path. The path is public detail db order items. Okay, and then order items dot count. Let me see the syntax. I forgot. I'm not using Pig at all these days, so I forgot the syntax. But I have GitHub code. Yeah. So this is how you have to load the data. Now I understand what is happening here. Okay, it's not brackets. It is not a function. It is just an operator. Load is the operator here. It takes the path. Now it loaded the data into. They call it as bag. Bag is nothing but collection. Okay, and each record in this bag is called as tuple. They use the similar terminology like Spark. Okay, so load will actually load the data from from that file system, which is from those files which is in HDFS into and it will make the data ready to be processed. It will not load immediately. It will only load one when we run certain commands. Until then, like in Spark, it also creates a graph internally or tree internally to to determine how to execute whenever certain action is performed. And the actions which actually trigger the execution is dump, and there is one more, save. Save is to write back to HDFS. Dump is to dump onto the console. Okay. So that being said, I mean, this is the example for WordCon program. If you want to iterate through the elements, and then if you want to convert your lines into different words as records, then you have to use something called flatten, tokenize, etc. And then you have to use group by, and again you have to use for each to process the data. It is almost similar to Spark. If you develop the WordCon program with Spark, it will almost similar to this. Okay, so this is how the pig scripts will look like. So I'm not getting into too many details here. If you are interested to learn pig, you can go here. Only scenario where you might be seeing pig still in the real world is um, where they try to re-engineer the pig scripts into Spark programs or high queries. So those are the type of projects which you might lead into with respect to pig. Otherwise, I don't see any new project starting with pig. Spark gives you a lot more flexibility and simplifies a lot of things with Scala or Python, and hence people are not using technologies like pig. Okay, just give me a moment. That being said, even if you want to learn pig in detail, I have videos also. I have created some material long time back. Now let us. So this concludes the overview about data processing technologies. Hive, Spark, Pig, all these fall under data processing technologies, especially in batch. Okay. For real time, we typically talk about databases such as HBase, Cassandra, MongoDB. I have covered already MongoDB in the as part of database essentials itself. HBase and Cassandra are also fundamentally similar. Okay, and then next comes the data ingestion technologies. And what are the data ingestion technologies? Scoop, Flume, Kafka, etc. And I'll be covering overview about all these three: Scoop, Flume, and Kafka. Okay, so first let us understand the purpose of these things. So I am actually creating a new PPT. Actually, let me open the existing one. I don't need to create new actually. Open recent. Introduction to yeah, this is the one, building EW using Hadoop. Okay. So you can see this picture. We get data from different sources. The source can be OLTP. OLTP stands for online transactional processing, which are nothing but and the databases supporting the OLTP are nothing but RDBMS type of databases. It is Oracle, MySQL, Postgres, etc. And then the data might be coming from mainframe systems and also external applications. And typically from external applications, we might get using queues, JMS queues or Kafka queues or whatever it is, some queuing mechanism. Okay. So to get data from closed mainframes, because mainframes is highly proprietary, highly secure, and very closed black box kind of environment, there is no straightforward way which we can use all the time to get data from mainframes. So for that reason, what they do from systems like mainframes, and also for those where external folks are controlled to access, they actually give the data in the form of CSV files or whatever file they want. Okay. When they say when I say they give the files, they fetch the data for you, and they write into file, and they save the files wherever you want, wherever the downstream guys want. In this case, downstream guys are the developers building applications for the big data cluster. The middle one is big data cluster or Hadoop cluster. Okay. So once you get those CSV files from external applications into means to push into the cluster, typically we first get the files into gateway node. Okay. Once you have those files in gateway node, you can use commands like Hadoop fs -copy from local, Hadoop fs -put, etc. to copy data into HDFS. But they don't run manually. They will build application, and to build application, the directory names has to be some standard format. For example, if I have to run the load once every hour, looking at the directory name itself, I should be able to figure out when the directories are loaded. And also, we have to develop a framework using those commands in such a way that we can keep track of what is being successfully loaded, what is being failed, what is being currently running, etc. This is called as data integration frameworks, which we need to develop using commands like Hadoop fs, and around that using programming languages or scripting languages. Okay, even Hadoop fs is kind of a data ingestion mechanism. Hadoop fs -put is a data ingestion mechanism. Typically, people use Java programs with necessary HDFS APIs. But nowadays, people rarely using that. You can use Spark or other approaches, or there are all. If the project is there for quite some time, there will be already a predefined framework which you just have to use. Hardly there will be a requirement where you have to develop from scratch. If you have to develop from scratch, you have to use Hadoop fs commands or the corresponding APIs that comes as part of Java programs that are used to build HDFS, and then you have to write your own Java programs. Okay, so that is one thing which can be used as data ingestion tool when you are getting data from mainframe systems. Then RDBMS. So when you have data in RDBMS, one of the most prominent tool we use is Scoop. So using Scoop, you can connect to the source database, and you can get the data into HDFS and vice versa. You can also get the data back into database. So in this case, if you look at this picture, we get data from multiple sources: OLTP, closed mainframes, and external apps, either in real time or batch. So the arrow between the first rectangle and the second rectangle tells that data is coming from those into big data cluster. And as part of the big data cluster, you have our Hadoop cluster, you have bunch of nodes. Okay, and we perform ETL within the cluster. We process, we get the data which is already in HDFS, process it, and save it back to HDFS. Once it is saved back to HDFS, sometimes we might push data to reporting database. Okay. So when the data is pushed to reporting database, we can connect our visualization tools to that, and we can report out of it. And this push of processed data from big data cluster into reporting database can be done by Scoop. Okay. So there are two main commands in Scoop. One is import and other one is export. Import is to get the data from OLTP databases in this case into HDFS or Hadoop cluster. Export is from cluster to external database. Okay. But between import and export, you have to use some technology to process it. Typically, it is Hive, Pig, Spark, or whatever data processing technology you want to use. Okay. So now let us see brief demo about Scoop. Again, Scoop I will be covering a bit extensively in 2-3 classes. So briefly, I will give overview about what is Scoop, and then we will move forward. And I will just run one Scoop import job just to understand how the syntax look like. So in this case, I am coming out of this. And Scoop command starts with Scoop, and there is no like if I just type Scoop and hit enter, it will not launch command line interface like Hive or Pig. Each individual command will be executed and the control will come back to Linux. Whereas with Hive or Spark Shell or PySpark or Pig, the context will change to their proprietary command line interface, and only their respective commands will work. In this case, when you type Scoop and hit enter, it will just treat as individual command. There is no command line interface for Scoop. You can just issue list of Scoop commands using Scoop as the main command. Okay. So in this case, they are saying use Scoop help if you want to understand the usage. And these are the high level commands which Scoop supports. And out of all these things, import and export are the main ones. On top of import and export, you also should know the purpose of eval, the purpose of list databases, list tables, etc., which I'll be covering. And also, once I cover Scoop, I will go back to shell scripting and I will give you an exercise where you have to integrate both shell scripting as well as Scoop. Okay. So that being said, to use Scoop commands, you have to start Scoop and then some command. In this case, I'm trying to import the data. Okay. And let's say I want to import data from a MySQL database. So you should know how to connect to the MySQL database. What is information that is required to connect to my any database? What is that? What is the information that is not correct? What is the information we require to connect to the database? Tell me what is the. That's why you should at least execute what I have explained, the JDBC programs and all those things. So when you write Scala to connect to MySQL database, what all you use to connect to the database? How you connected to the database? How did you connect to the database? The question is, what information you used to connect to the database? Yeah, username, password. But you need to know where your database is. How will you go there? Username is and password is correct, but without they're like key. Username and password is like key. You have the key, but you have to go to somewhere to use that key and open it. What is that? No, that is not correct. Where databases run? What is that? Huh? The cluster is means not. It is correct, but it's just a fluke. You really did not understand. It's not cluster, but in some cases it's cluster also. But there is a more fundamental term than that. What is that, Vamsi? You told. Can you open the Scala program where we have connected to the database and see how we connected to the database? So you need to have host name or IP address or public DNS. So public DNS or host name or IP address are the ones which we typically use, and there should be a connectivity between the node from which we are trying to connect and the other node. Okay, so in this case, the database is running under ms.itversity.com. It is just a public DNS. Its address to connect to a host. Okay. First, you need to validate whether you are able to connect to that. So ping is the command which you can use. Again, this ping or telnet which can be used will work only if firewalls are not blocking. So you can block ping and you can open for some other activities. So there is a firewalls. If you could not ping, it might be blocking. Anyway, so if ping is working, then you are able to communicate with that, with the host. Okay. So what is ms.itversity.com? So let me open PPT here. So this is a host. What is host? What are the main components of host? Don't talk about software from the hardware perspective. What are the main components of host? Fundamentally, what is a computer? What are the main components of your laptop? Memory, CPU, storage, or hard drive. Network is secondary. Primarily, these three are important. Even without network, you can use your computer. So memory, CPU, hard drive, and then next important things are monitor, keyboard, mouse, network cards, etc. Right? So once you have the hardware, so this represents the computer which have memory, CPU, and hard drive. What is the first thing which we install on this operating system? Okay, so there will be operating system which will be taking some memory and some CPU and facilitating you to work with a bit more intuitive interface rather than very naive interface, a bit more intuitive interface, such as Windows is example where they give nice graphical user interface. Unix will give command line interface by default, etc. Okay. So once you set up operating system, on top of that, we set up additional softwares. And what are those additional softwares? If it is your PC, it can be Microsoft Office, it can be media player, it can be browser. All these are different softwares which you have. Typically, if you want to install database, you need to pick the respective proper technology which you are interested in, MySQL or Postgres or Oracle. Like you have different types of media players, there are different types of database also. Whatever database you want to choose, you have to download that and you have to install. And in your system also, there will be some services which will be running all the time. Microsoft Office, you typically launch whenever you want and use it. But there are some services which will be running all the time. For example, if you are working in an office, you might have Outlook, which is up and running all the time, or Skype, which is up and running all the time. Okay. So the term which we use for the process which are up and running all the time are background process or daemon process. Okay, so database is also technology which it is unsure when you will get the data, but whenever it gets the data, it has to process it, or whenever someone requests data from the database, it has to return the results. So it also requires a background process to be up and running all the time. Okay, so you have hard drive. So let me change the color of this. So once you download and install, what happens on the hard drive? Let me add hard drive to this. Typically, there will be more than one hard drive. Okay, like this. And these hard drives are primarily used to store the software of your database. So when I said download and install MySQL, so with Linux, what is the with CentOS or Red Hat, what is the command to download the packages and install the packages? What is that? Sudo is not the command. Okay, sudo is to run as a super user. apt-get is the command if it is Ubuntu. If it is CentOS, what is the command? Sudo is just to elevate the user to run a particular command if he can be elevated. Sudo itself is not a command to download and install packages. If it is CentOS or Red Hat or Fedora, it is yum. If it is any Debian flavor operating system such as Ubuntu, it is apt-get. Okay. So when we say yum install apt-get, what it will do? It will connect to the whatever database repository. It will download and it will copy the necessary software on this hard drive. Okay. So there can be a directory like this /user. Sometimes we save it in OPT, sometimes we save it in user. It all depends upon how you organize. And then probably MySQL. And that is where all the compiled programs supporting the database will be saved. Okay. And then when you create a table, data has to be stored somewhere, right? And that data will be typically network mounted. It will not be local. It can be local also, but in production clusters, it will be network mounted. For now, for the heck of it, let's say data will be on the same hard drives, which are local. So typically it will be like data MySQL, something like that. Directory will be like that. And whenever you create table, the files which supports your table will go to this location. So there is a location for your software. There is a location for your data. Okay. Now to copy the data, to get the results back for your queries and all, there has to be a daemon process running or background process running, and that is called as MySQL D or MySQL Server. Okay, so typically the database process is represented using cylinder. Typical process are represented using this icon. Okay, but database is actually represented like this in most of the cases. Okay, so I'm drawing like this. So this is nothing but a process. What is a process? Process is nothing but it takes CPU and memory, some memory and some CPU, and it will be running all the time. Okay, so this is MySQL D or MySQL Server process which is running. Okay, so whenever there is a process that runs all the time, typically it has a port associated with it. Okay, because if I just say this entire stuff is ms.itversity.com, right? So when let's say this is our host, and let's say its name is ms.itversity.com. You might have database server like this. You might have some other server. Okay, let's say some web service running on this. So let me draw that also. There can be n number of services which might be running on this. Like your PC might have Outlook running, or Microsoft Office running, media player, chat apps such as Skype. All those will be running on your PC. Similarly, even there can be a number of applications that are running. Okay. So if I would try to just connect using ms.itversity.com, to which software process it should connect? That's why we have port number associated with each of these process. For MySQL, the default port number is 3306. So if we do not specify port number 3306, as long as we pass rest of the information and as long as it can be understandable that it is related to MySQL, it will use 3306 as port number. Same way as HTTP. HTTP means it will go with 80, port number 80. What is that? I told 80. Somewhere you got 8080. HTTP runs on 80. Why are you saying 8080? I have many URLs. I have 8080. I have 19,288. I have many other things. If the port is not specified, HTTP try to connect to some service which is running on port number 80. Similarly, if it is HTTPS, it's 443. Okay. If it is MySQL, the default port number is 3306. You can run on any port, but if you use any other port, you have to explicitly say along with the other information. So now what are the information we need to connect to the database? Avinash, what is the information we need to connect to the database? I didn't ask you. Why are you responding? Tell me, what do you need to connect to the database now? Address means IP address or host name, along with port number. So that tells where your server is. Now you need key. The key is username and password. Okay. And also when you have, if you go to a bank, you can only open your locker. You cannot open others' lockers. So you have to be authorized with that key. So there will be controlled access for you. You will not be able to access everything in the database using that username and password. Whatever is accessible to you, only those things you will be able to. Otherwise, you will be getting issues like insufficient privileges, permission denied type of errors. Okay. So now we have host as ms.itversity.com and the port number is 3306. So now if you have MySQL client installed, where it should be installed, from wherever you are trying to connect to the MySQL databases, that server should have MySQL client. So in this case, I'm trying to use GW02. Okay. If you have MySQL client installed, you can say MySQL and hit enter. If it does not throw an exception saying that no command found or no file or directory or whatever it is, that means MySQL is there. So in this case, MySQL client is there. Even without client, there are other ways to connect, and I will explain at a later point in time when we talk about Scoop in detail. So MySQL, first we need to tell to which MySQL server we are trying to connect. Means the host information we have to pass. Host information can be passed using -h. Okay, and we can give the DNS alias or IP address. IP address is nothing but 192 something like that, which will be numbers with 3 dots in between. Okay, so we can either give the this one or even this one. This is the actual physical address, and this is alias. Okay, so MySQL -h, I can use either of them. If you want to pass the port number, you can say -P. If it is default, you can ignore. If it is not, you can say like this. Okay, and then username. So you have access to the database by using username retail_user, and typically you have to use -P because you have to use enter password. Having all this information is not enough. You need to have a password also to connect to the database, and hit enter. Now it prompted for the password, and ITversity is the password. You can hit type ITversity and get into the MySQL database. Okay, now I have, as part of database essentials, primarily I have covered Oracle, not MySQL. Okay, so connecting to Oracle instances is a bit different. So depending upon the database you are trying to connect, you just have to figure out what is the information it is required, whether the client is installed or not, and then you should be able to connect. For most of the databases, these are the informations which you need to pass in one way or the other. The syntax might be different, but you need to have a host name or public DNS or alias or port number, username, and password. These are the 4 minimum things which you need to be aware of. Okay, and now to list the databases for which this user access to. Okay, you just have to say show databases, and it will list the databases for only those for which this user have access to. He will not be able to look at other details. So this retail_user have access to retail DB, retail export, and retail results. Information schema is a system schema. Typically, we don't touch that. Okay. Now, if you go to retail DB, what is that? Yeah. If you want to, out of all these 3 databases, if you want to connect to one database, you can say use, and you can connect to that particular database or switch to that particular database. Okay. Now to list the tables, show tables, and these are the tables we have. Now let's say I want to import this table, which is in MySQL database, into HDFS. I can use scoop import command. Okay, so I can say scoop import. So scoop import is not MySQL client; it's a scoop related command. And the way you can use any other application than the corresponding client of the technology, either we use ODBC or JDBC. These 2 are the approaches which we use to connect to a database. Did anyone try to connect to the database using ODBC on a Windows laptop? No. ODBC means, anyone have idea about ODBC? What is ODBC? Okay, Oracle. D for data. Okay. C for cinema. ODBC stands for Open Database Connectivity. Okay, and that was the legacy approach of using. So we typically, if you have a client on your PC, and if you want to connect to a database on your Windows PC, we create something called ODBC connector, and using the ODBC, we actually connect to the database. Okay. The alternative way of doing it is so ODBC requires a client to be set up on your PC. Without client, you will not be able to. Alternative way is JDBC, because all the laptops comes with JVM. Okay, and if you have some tool which can use Java based drivers, you should be able to connect without much issues. Okay, so JDBC is much lighter weight. You just have to download the jar file from the vendor, which says like ojdbc.jar for Oracle, MySQL connectivity.jar for MySQL, etc. So you just have to download that jar file, place it in some location, which means registering the jar file for the usage, and then whenever you try to connect your client to a database, you have to pass something called JDBC URL. And this JDBC URL also uses the same information: host name or IP address or public DNS, port number, username, and password. That's what we have done as part of our JDBC program using Scala, if you recollect. Okay. So now with scoop import also, we need to pass the JDBC URL or JDBC URI. And so we need to use a control argument to tell what we are passing. So the control argument to pass the JDBC URL is -- connect. And then you can say JDBC MySQL host name, port number, and database name. Let's say I want to connect to retail_db database. Here I'm just using it for line break. Okay. And apart from this, we apart from IP address, port number, database, we also need to pass username. So we can say username. In this case is retail_user. Password ITversity. And then what we are trying to do with scoop import, we are trying to read the data from this from one of the tables in the database and write it to HDFS. So we have to tell what is the source table name, what is the target directory to which we want to write the data. Okay, the source table name can be passed using table, and we can say orders, and then we can say target directory to specify the location in HDFS. So it is nothing but user training, and you need to have, so whoever is running this command has to have permission in this on this location, only then he will be right. Okay, so in this case big data bootcamp demo orders. Okay, so now we have all the information. We are saying connect to the database, fetch the data from this table, and write the data to this directory, and hit enter. Now it will create a Mapreduce job, connect to the source database, and get the data and write back to HDFS. All these things will be taken care. I will explain how it happens at a later point in time. For now, just understand how to use, means the purpose of scoop import. It's primarily to get the data from remote database into HDFS. If you want to perform the operation other way around, you have to use scoop export. Okay, even export requires the same connect username and password. Table will be target table, and we have to say export directory instead of target directory. We have to say export directory, and we should be able to write the data into MySQL database or whatever database you want to write into. Now you can see that the job is successfully done. You can get the information. There are 68,883 records. All of them are saved to HDFS. And then we can say Hadoop fs-ls user training bootcamp demo orders, and we will be able to see the data. Why there are 4 files and all those things, we will see later. You can pick one file for now. And then use tail command to see the output, just to confirm that data is saved. And you can see data is saved with comma as delimiter. Each field is saved with comma as delimiter. Okay. So this is brief overview about Scoop. It is primarily a data ingestion tool to get the data from source and then write into HDFS. So typically, when we try to get data from source databases like this, we run these jobs once every day, and we will try to capture the delta and preserve into HDFS. So we'll be mostly reading the static data. Even though data is being added to the table, we only read the static data based upon certain timestamp. For each day, we will be capturing data after the day is passed and load into the uh, downstream databases like big data clusters. Okay, so we will see those details at a later point in time. Now, sometimes we might want to uh, read the data in real time. Okay, one example is what we LinkedIn endorsements. Okay, if you guys endorse me, the data should be refreshed as quickly as possible, and people should be able to view the report as quickly as possible. And for that, we cannot wait until the end of the day and run it. We might have to make it much quicker, probably a minute or two. Okay. In those scenarios, we cannot use tools like Scoop. It's very heavy to run Scoop every 2 minutes and get the delta. Rather, we use something called streaming technologies, and that's where Kafka, Flume, all these things comes into picture. Okay, so on the so again, if you have access to the lab, we have a application called Gen Logs. It will generate logs simulating a website traffic. Okay, and it has three shell scripts. One is start underscore logs dot sh, and then stop logs dot sh, and then tail logs dot sh. If you look at tail logs dot sh, right now it is not running. So we just have to say start logs dot sh. Just give me a moment, okay? Okay. CD opt gen logs. Okay, now if I say tail logs dot sh, you can see it is being refreshed. So what is actually that mean? So whenever you develop a web application, it can be Java based application, it can be JavaScript based application, it can be anything. You web applications are those where you will be building a archive of all your classes, and you will be deploying on either web server or application server, like Apache Web Server or Tomcat, whatever it is. So as part of the jar file, typically we will be using something called log4j. Okay, and we'll be logging the messages. So what kind of messages we log? For example, if you are trying to connect to the database and update write object into a database table, for the troubleshooting purposes, as part of our code, we will use log4j APIs and say, okay, at this time we are trying to connect to the database to a particular table. At this time we are trying to insert. Insert is successful. If it is successful, if it is failed, insert is failed, so on and so forth. We log information like that, and those will be logged into some standard location, typically /var /log, whatever the architect decide for the application. Okay, so these days, instead of writing some of the information, some of the critical information into the database, the applications write the information into log files. So, for example, if a company like Walmart or Flipkart or IRCTC want to see when people are logging in, what type of activity they are performing, what all pages they are visiting, and all, if they try to store all this information in a database, the database will be unstable. It is too much for it to manage. So rather than storing that information, and that information is only required for analytics at a later point in time. In real time, it doesn't add any value. Okay. So to address this, to offload from the database, they started writing this information into the log files, saying that this is the IP address, this is the timestamp at which someone tried to access, and this is the endpoint, which is nothing but the page in the website, and other things, other relevant information. So using this information, they can actually see if from which location people are coming more to the website and all those things. They can get into the insights easily. Okay, so this information will be logged into log files. So this application Genlogs is just a simulator, as if someone is visiting on the website and accessing multiple pages in the website. That's why you have IP address, timestamp, etc. There is no web application as such, but it actually simulates as if the web application is writing log messages into a log file. Okay, and this actually gives you the capability to understand how you can ingest this kind of data into HDFS. And what are the technologies you can use to load this kind of data into HDFS? It can be Kafka, it can be Flume, it can be several other technologies. Okay, if it is Kafka, I will get into the details with respect to Kafka later, so I'm not going to cover much at this time. There is something called Kafka Connect. Okay, using Kafka Connect, you can configure to read data from this location where we have this log files are being generated. So we need to pass this location, and then it will read the data from that, and it will copy into a queue, Kafka queue, and someone else can actually register to that queue and start consuming the messages. Okay, same is the case with Flume. We can use Flume. Flume also have something called agent. That agent has three things: source, channel, sink. These are the three things they have. Source will be typically connected to this, and sink will be connected to the HDFS, and you can queue up this data. So instead of writing each and every message to HDFS directly, you can queue up to a minute or 5 minutes or 10 minutes, whatever time frame you want, and you can save all those messages, group it together into one file using technologies like Flume or Kafka. Okay, so that is the purpose of streaming tools. I will show the Flume agent for now, but we will get into a lot more details with respect to Flume, Kafka, etc. at a later point in time. So I think it is under IT Varsity. I already have some code. Yeah, this is the one. Find Flume. Yeah. Okay. So if you look at this file, so this is primarily to read data from weblogs into HDFS. Okay. I will get into Flume architecture and all those things at a later point in time. But a typical way you start Flume agents is you need to identify the source and you need to identify the sink, and you have to set certain properties with respect to source and sink. So in this case, this is our agent name which will be running. WH is the agent name. So your properties has to start with your agent name. Okay. And any Flume agent will have one or more sources, and then one or more sinks. And for each source and sink, there will be a channel. Okay. So you need to have a typical Flume agent will have one source, one channel, and one sink. Okay. So in this case, we have the source name as WS, sink name is HD or HDFS. It's just name, and channel is memory. I will explain what is this memory channel at a later point in time. Don't worry too much about it. So when it comes to source, we have to tell what you are trying to do with the source, and there are n number of sources it supports. It can read data from streaming log file, such as access.log, like we have seen. There are some more advanced sources, such as TCP. I forgot. We can actually go to the documentation, and then I can tell what all sources it supports. Flume user guide. And one more thing is Flume is also dying technology. Flume will not be there after 2-3 years. Okay, Kafka and Kafka is one of the very good technology which you should focus on for streaming analytics. Okay, and Kafka is the most important tool as of today for data ingestion as part of streaming analytics. It's a data ingestion tool. It's not data processing tool. It's a data ingestion tool. We are trying to get data from streaming web server logs into HDFS or some other target to process the data further. Sometimes we write to HDFS. Sometimes we give the data to something called Spark streaming APIs, and Spark streaming will digest that data and process it. So with streaming analytics, you have to use multiple technologies to process. Kafka is just an ingestion tool, not the processing tool. There is a plugin called Kafka Streams, which can also do processing. But within big data ecosystem, we don't use Kafka Streams that often. We use Spark streaming, okay, or Storm or Flink. That being said, you can see list of sources that are supported: Thrift source, JMS source, Twitter source, Kafka source. You can actually get data from Kafka also. Syslog source. This is what I was talking about. So Syslog TCP source. So you can also get the log messages over the network also. That is what syslog is. Okay. Like this, you can get data from different sources and queue up the data up to a window and then save it into HDFS. If you don't do that, there will be one file created for each and every record, and it's very expensive operation. Okay. So that's what. So one of the source is exec type, exec source. and all it requires is, if it is exec source, we need to pass a command. What is the command we want to run? This is the command which we want to run. What is this command? It is nothing but consistently seeing at the tail of the file and get whatever data it get at regular interval. Okay, so we are running this command and we are getting data uh, using Flume agent. And then if you look at the configuration file, I want to write to HDFS. I will explain all these things later at a later point in time. Okay, so here we are saying what is the path to which we want to write in HDFS, and then what is the file prefix, so on and so forth. I will explain why we have to specify this prefix at a later point in time. I mean, now once I run this. Okay, the most important path is, so the most important argument value which we need to pass for sync is the path to which we want to write the output. And then here you can see there are three properties which have roll in them: roll interval 120, roll size 1 MB, and roll count 100. So roll interval is 120 seconds, roll size is 1 MB, and roll count is 100, which means create a new file for every 100 messages, or every 2 minutes, or every 1 MB, whichever happens first. Okay, so that is the meaning of having all these three properties here. So whichever event happens first, it will trigger a new file internally in the file system. Now I am coming out of this, and the way you can start Flume agent is by using command called flume-ng, and then agent, and then you can say -n, and this name has to be the first two characters or whatever name we have given for each property in the beginning, before the first dot. In our case, it is WH. Okay, and then you can actually pass configuration file whdfs.conf. So this one and the first part of each and every property which we have defined in the file should match. The agent name is nothing but the first few characters before that first dot in each and every line. Okay, and now you can run this. So what it is doing, it is creating a web service which is called as Flume agent, and what it will do, it will consistently read the data from web service logs by issuing the tail-f command, queue up the messages until one of those roll argument is done, and it will write into HDFS. Okay, until that timestamp, until that roll is done, it will create a temp file. Once that one of those threshold meets, it will rename this temp file to this file, and a new temp file will be created. So temp file is only until that roll threshold is met. So we need to wait for some time, either to get 100 messages or 1 MB or 2 minutes, whatever is the earliest one. Also, you can copy this path. Okay, why it is not writing? Yeah, now it wrote. So now you see the previous file have some data in it, and a new temp file is created. Okay, so if it is saying 0, that means it is still not flushed out into the hard drive. It is not HDFS. It is only maintaining that information in memory. Okay, that's why it is showing 0. But whenever that threshold met, whether it is flushed out into temporary file or not, it will flush out into the main file, and you can see the output here. Okay, so this is Flume. So the way we are reading data from weblogs using Flume, which have source, channel, as well as sink. The same way we can do it with Kafka. Source can be replaced with something called Kafka Connect. Channel can be replaced with something called Kafka Topic, and sink will be replaced with something called Spark Streaming. You cannot directly, or you can actually use again Kafka Connect. So Kafka Connect is source to read the data from source. Kafka Connect is also sink to write into HDFS. And in the middle, we have something called Kafka Topic that you will understand when we actually get into Kafka a bit in detail. Kafka is a bit uh, time. It will take some time to get started itself. That's why I'm differing for now. But you have to spend more time on Kafka, not on Flume. Flume is dying technology. Flume will be replaced with Kafka very soon. Even today, even if companies are using Flume, it is only to address one particular scenario where the existing code cannot be modified to write into Kafka directly. Okay, I will explain that scenario at a later point in time. Don't worry too much about it. All you need to remember at this time is Flume is a dying technology. You need to focus on Kafka and then some streaming technology like Spark streaming or Storm or Flink. Okay, so that being said, now let us go back to Ambari and see what all are covered so far and what all are missed till this time as part of big data ecosystem overview. We are still talking about overview only. We are not actually getting into the actual topics with respect to a particular technology. And we'll be starting with Hive and then Spark, and we will take some time on Hive and Spark, and then streaming technologies as we proceed further. Okay. So that being said, I have covered HDFS, Yarn, MapReduce. Tez, you don't need to worry too much about it. It's hot and work specific. If you use Tez, you can run your pig scripts or Hive queries in Tez context also. But Tez is also dying technology. Spark is a better alternative than Tez. Okay, and then Hive. I will cover HBase also very soon. Probably next week I will spend some time on HBase before getting into Hive. I have covered Pig, Scoop. I haven't covered Uzi. I'll not be covering Storm. I'm also naive in this area. I have covered Flume. I have covered Kafka, Spark, and Spark 2. Only thing that is missing in this list is Storm, Uzi, and HBase, and I will be covering HBase. Uzi is also not very important skill. It is primarily to define the workflows. So, for example, if you go to the presentation here, what I have mentioned earlier, you get data from multiple sources. You get data from multiple sources into HDFS. So let's say there is one dataset in OLTP, one dataset in mainframes. And if I have to get some insights by joining these two datasets, until I get data from both the sources, I will not be able to process further, right? I cannot join the datasets and I cannot do any aggregations on top of it or data processing on top of it, right? So I have to wait until I get the data from all the sources. Once I get data from all the sources, it should automatically trigger what should be the next step. Probably next step could be joining those two and then performing the aggregation. Once that is done, probably I might want to run scoop export to write data back to reporting database. So you need to define something called workflow. Get the data from multiple sources, wait until data from all the sources is retrieved, then do the data processing and ingest data to the reporting layer. So this has to be taken care by either programming or some tools. Uzi is one such tool which will give you the flexibility to define workflow using all these big data technologies. But Uzi has its own challenges and issues. The more robust ones are like LinkedIn Azkaban. Let me spell it. Azkaban, it is from LinkedIn, or Airflow for Airbnb. If you are from enterprise world, you might have heard about tools like Control M, AppWorks, etc. Those are enterprise scheduling tools. Azkaban and Airflow are open source tools. So enterprise scheduling tools are Control M, AppWorks, etc. So all these things can be used to define workflows and schedule them. So they are not only capable of defining workflows, they also have scheduling capacity. Uzi also have both workflows and scheduling, but Uzi these technologies are better than Uzi. Okay. Anyway, we are not going to cover these things as part of the course. Also, all you need to understand is the purpose of Uzi, and if you are interested, you can actually explore it. But if you want, I would recommend you to go through Azkaban or Airflow rather than Uzi. Okay, so that is about Uzi. So only thing which I will be spending some time next week is HBase, and then we'll get into Hive. Yeah, AutoSys is also enterprise scheduling tool. Yes, Srikar, you can use it. Okay. So that being said, any questions? So Kamlesh is asking, do we need to install Linux or Ubuntu system on local laptop to use Scoop command or any other big data tools locally? Yes, Kamlesh. So Scoop doesn't work. Yeah, this. You need to have a MySQL database. You need to have HDFS. You need to have Yarn. Then only you will be able to use Scoop. So it's quite cumbersome to set up on your PC. And on Windows, you will be running into one or the other issues. If you are interested, you can set up something called Cloudera Quick Start VM or Hortonworks Sandbox on your PC, which will give all these technologies to you. Don't spend time on setting up plain vanilla Hadoop or plain vanilla tools onto your PC. Okay, try to set up Cloudera Quick Start VM or Hortonworks Sandbox. But they require at least 16 GB RAM on your PC. If you have less than 16 GB, I don't recommend you to spend time on setting up environment on them. It can become counterproductive. However, you will get access. You already got access to the lab for 1 year, so better to use lab. Okay. Any other question? Okay, then we'll catch up tomorrow. Thank you. Bye. And I will be taking care of uploading all the this week's videos by tomorrow. Okay. Bye.